Hi everyone, my name is Sophie and welcome to our Prelim Standard Maths July lecture. I'm super excited to be here with you today. My name is Sophie. This is a 2-hour pre-recorded lecture. I'm going to explain how it works in just a second. Thank you so much for being here. The first thing I would just like to mention is ATAR Notes. ATAR Notes is who you're with today. I am from ATAR Notes. We are a nationwide HSC, VCE, QCE, nationwide Year 12 support system for students. We provide high school resources. You can enter atarnotes.com/register to find out more. This is a little bit of an overview of what we provide. We have hundreds of downloadable study notes. We also run these lectures 4 times a year. They're always free. We have discussion forums and online Q&As. We have engaging online revision through videos on our website. We also publish newsletters. We have an ATAR calculator on our website as well. We also publish articles and heaps more. So again, head to atarnotes.com/register to check out those resources. Those are our free resources. If you're looking for something paid, we have 3 main paid options. The first is TutorSmart. TutorSmart is who I also work for. This is how we provide tutoring. We provide 90-minute weekly classes for all of your subjects, and we also provide private tutoring in our slots. They are incredibly valuable sessions. I think that they are super important if you're struggling with something more individual and you need some tailored assistance. So you can head to atarnotes.com/register to check that out. TutorSmart, look up TutorSmart. You can also have a look at our study guides. These are available in our bookshop. They're printed revision materials and they are amazing for helping you get those top marks. And then finally, if you want those revision materials online, head to Ed Unlimited. That is we call it Netflix of the HSC, or Netflix for the ATAR. Head to Ed Unlimited again to check out those study guides. We'd just like to say a special thanks as well to La Trobe University, RMIT, Deakin, UTS, and Macquarie for helping us put these lectures on for you. So how will today's lecture work? So this is a pre-recorded lecture with a live chat. So the person in the chat is me. I am in the chat with you right now. It is just me on the day that the lecture is running. So it's a pre-recorded lecture. I can't engage with your questions verbally. So if you're asking something, I won't be able to answer you now, but I will answer you in the chat. This lecture will run for 2 hours. Any questions, use the chat. Again, I will be active to answer those questions. I would also recommend downloading the slides, which you can do at any time. That way, if I move too fast or too slow, you can move at your pace, whatever necessary. Finally, this video will also be available after the lecture, and it'll be available on the website where it is. So once the 2 hours is over, the video doesn't disappear. You can scroll back and forth and revisit the sections that you need to revisit. So what topics are we covering? We're going to cover 4 topics today. We're going to look at linear relationships from the algebra topic. We're going to look at budgeting and household expenses from the financial mathematics topic. Look at summary statistics from the statistical analysis topic, and relative frequency and probability from the statistical analysis topic. So our first half is going to be linear and financial, and our second half is going to be statistics and statistics. So it's a nice big hour of statistics in the second half. After all of that, we will wrap up. So a little bit about me is how I'm going to kick this off, just so you know who is talking to you. Then we're going to do our content block 1. Ignore that 5-minute break. There will not be a break. That's a mistake on my part. So we'll do content block 1, content block 2, and then we will wrap up. You can see along the bottom, which will be either side of me, I can't remember which side I'm facing, there's a little scroll, and the blacked out part is the part that we are on at the moment. So if at any point you're lost on what content we're looking at, that is where you can get your bearings. So a little bit about me. My name is Sophie. I graduated in 2020 from Bethany College in Hurstville, and I got an ATAR of 95.6. I studied English Advanced, Standard Mathematics, Studies of Religion 1 unit, Modern History, History Extension, and Society and Culture. In Year 11, I also did English Extension 1 and Ancient History, if those are subjects you're doing as well. I did those in Year 11. I dropped Ancient History at the end of Year 11, and I dropped Extension English in the middle of Year 12. That's simply because I only wanted to do 10 units. Standard maths was my best subject. I got a band 6. I'm currently studying a Bachelor of Arts and Laws at UNSW. If you have any questions on that, feel free to drop them in the chat, and if they are something that I can get to, I will get to them for you. I have a beautiful German Shepherd named Luna and a very annoying cat named Jody. If you hear the cat, that's her. If you hear a dog, that's Luna. May as well introduce you to everyone at this point. I would say I was a bit of a teacher's pet, but in a hopefully somewhat of a cool way. I don't know if it's a cool way. I think maybe writing it this way denotes it being a cool way. But that's me trying to say that if you feel like you care a lot about the HSC and you feel like you care a lot about school, that's fine. You shouldn't be made fun of for caring about something. And the fact that you're here shows that you care. So I appreciate your initiative. I guarantee I procrastinate more than you. I procrastinate a lot. And if you have questions on procrastination, you can ask those as well. And then finally, one of my tips for the HSC. I know this is a little bit premature for you guys, but I would really recommend doing something afterwards. I know that all of my HSC students are really looking forward to their plans. I went camping, cheap way to do it. But for now, try and plan something that you can enjoy after those prelims are done. So how are you supposed to study for maths? First things first is looking at where you guys are in your year 11 and 12 journey. Starting now, you still have plenty of time. If you are struggling, there is still plenty of time to get your footing. If you feel like you haven't even really gotten into that year 11 mindset yet, it's okay. There is time. Obviously, prelims are coming up, but again, there's always time. It will be much less overwhelming if you do some early groundwork now in year 11. And I can kind of explain why this matters more for maths than it does for other subjects. When you move to year 12 for other subjects, you're starting new content. When you move to year 12 for maths, you are starting new content, but it's content that A, builds off of all of year 11, and B, it's the only subject in which you can actually be marked or tested on your year 12 content or your year 11 content. So 15 marks of your final maths exam in the HSC is going to be prelim content, which is really, really different to other subjects. Other subjects don't have that. They don't test you on the stuff you learned in year 11. But in year 12, in the HSC exam for standard maths, they will test you on 15 marks of prelim. So essentially, everything you have learned from the very first day of year 11 to the very last day of year 12 can be included in your HSC exam, which is why doing groundwork for prelim is important, because that stuff is going to come up at some point in year 12. Not only does it form the foundation of what you learn in year 12, but it is very likely that you will be tested on something that I teach you today in your HSC exam. I would also recommend keeping a rule book of some sort. This could be a book this big that you write down your formulas in, you write down notes in outside of your maths book. That's one way to do it. It's not my favorite way. My preferred way was to make summary sheets. So I say our textbook had 10 chapters. At the end of the year, I had 10 pages, and they were each of them a very clear, colorful, easy to read summary sheet that had all of the important formulas and diagrams on it. What I would say about that one caveat is it's one page and you want to restrict it. If you can't, if you have enough, you have more that you need to use to remember your formulas, or you want to write down a bunch of examples, that's probably when a rule book is best. Again, examples are super important, and I would recommend writing as many as you can down to come back to. Thirdly, try and figure out what you need help with and target it. So if there's something that you think is a problem for you, you do need to focus on that. And it's very tempting. I always tell this story, but I remember in year 12 that I found simultaneous linear equations quite easy, but I really didn't understand bearings and trigonometry. And I let myself do simultaneous linear equations because I didn't really want to deal with bearings and trig. And that came back to bite me. You need to focus on the piece of content that you don't understand. It's annoying. I appreciate that. But it will bring you so much better of a performance in the exam than if you choose to kind of neglect the things that you don't understand purely because you don't want to deal with them. There's always going to be someone who can help you. First of all, your teachers are literally being paid to do that. So please go to them first. And if you have unfortunate experiences where you don't feel like you're getting the best help, there is always tutoring. There is always online resources. There's a plethora of YouTube videos out there that will be able to assist you obviously I would recommend Shoot Smart or ATAR notes. There's also your peers. If you don't understand something, chances are maybe someone in your class does. There's always going to be someone who can help you, and sitting there thinking that you're all alone is not a very productive mindset. This one is a yes and a no. So study with your friends. I think it's a great point. I think it's important. I think it's a good way of bonding, and it's a good way of working together. However, you need to put restrictions on it. I was not a person who could particularly study with friends. I think I did it, but I didn't in specific circumstances. So I remember in lockdown, me and friends would sit on FaceTime and we would just mute ourselves and we wouldn't talk, but we would study together. And that was a good situation because obviously we were in lockdown. As a general rule, it's important that you pick the people that you study around. If you know you're going to get absolutely nothing done, then you probably shouldn't do it. But they're going through the same thing as you, and the only people who are going to understand what the next year and a half of your life is like, or the next year of your life, are the other people going through it with you. I know that I did it 3 years ago, but those memories are starting to fade, and it's not as clear for me. I don't exactly remember every little way that I felt in year 11 and 12, but your friends will, and I think it's very important to have that kind of bonding experience together. Take care of yourself. These next 2 years or year and a half, they're very intense academically. And it's very, very important that you don't neglect your mental and physical health too. I think most people do, to be honest with you. I know I did. And it's very hard not to because there's so many competing pressures. Number one, you're being told, look after yourself, take care of yourself. It's not that important. But then you're also being told, do all of these things that basically contribute to you having 6 hours of sleep a night, and don't take a lunch break, go and write an essay instead, or you skip sport, you need to study, whatever it is. It's very important you strike a balance. I think it would be much better to come out of year 12 with good mental and physical health than an ATAR that's 5 points higher. That's my opinion. I know that that's a bit rich coming from someone who did well. I understand that, but I think that it is one of the most important priorities that you can have. Okay, so let me know in the chat before we get started. What topic would you say you struggle with the most? Is it linear relationships, budgeting and household expenses, summary statistics, or relative frequency and probability? Just interesting to me. I like to see where students kind of rate themselves on those topics. While you type that into the chat, we will get started on content block 1. This is algebra, one of the 4 units. So remember, we have algebra, stats, measurement, and financial. This is algebra, and we're looking at linear relationships. So when we kick this unit off, I kind of want to explain that in standard maths, we have lots of different things, equations, relationships, formulas, and we model them through straight line graphs a lot of the time. A straight line graph is literally just a graph that has the y-axis, the x-axis, and a straight line running through it. So there are a couple of parts of that we need to consider when we think of what a straight line graph is. There should be a few that you're familiar with. You're welcome to type those in the chat as we go. As I said, we have a y-axis and x-axis. We also have the dependent and independent variables. An independent variable is when the outcome is not due to another variable. It operates on its own. A dependent variable is when the outcomes depend on another variable. I'm just going to let you guys screenshot that or quickly write that down. So again, independent outcomes are not due to another variable. Dependent outcomes depend on another variable. Let's think of this in terms of some examples. The independent variable might be the weather, and the dependent variable might be how many ice creams are sold. The independent variable could be the number of students that attend school, and the dependent variable could be how much money is spent at the tuck shop. Again, feel free to write some examples in the chat. I'll let you know if you're correct. One more, an independent variable could be the number of textbooks that are bought from the bookstore, and the dependent variable could be the amount of money that bookstore makes. So it's very important when we conceptualize these concepts that we think of them with examples that make sense to us. Okay, there we go. An example for you. Independent variable, the weather. Dependent variable, how many people are at the beach. 30 seconds to come up with 2 examples, enter them into the chat, and I will let you know if they are correct. Okay, so while you're doing that, I'll pop this up on the screen. How would we create a straight line graph? So we have some information here. We know that the weight of coffee beans is represented in kilograms, and we have a graph that runs from, from 1 kilogram bag to a 5 kilogram bag. We then have the cost. We have the cost for a 1 kilogram, 2, 3, 4, and 5 kilogram bag. I want you to take a guess. What could be our independent and what's our dependent here? Just before I switch to the next slide, what's our independent and what's our dependent? So our independent is going to be the weight of the coffee beans. This is because the weight does not depend on anything. We can just choose a weight. The cost is the dependent variable because the cost depends on the weight of the coffee beans. So independent variable is always represented along the x-axis, which is our horizontal axis. You can also remember this with the mnemonic device of HIV, horizontal independent variable, HIV. Not the best, but it works. And our dependent variable is on our y-axis. X-axis runs this way, y-axis runs vertically. Vertically, horizontally. Vertical, y, horizontal, x. So once we have that information, we've popped our independent variable, the weight of our coffee beans, on the horizontal, the x-axis. We have 2, 4, 6, 8, 12, and 10, 12, and 14. This graph, obviously, we've extended it now, 1, 2, 5, 10, and 15. So we could have 1, 2, 3, 4, and 5. But we've changed it just for the sake of this to 1, 2, 5, 10, and 15. And now we can see that we've labeled our y-axis with our dependent variable, which is the cost. So we see we've got $10, $20, $30, and $40, and we always start at $0. So what we've done here is plotted on some information. Let's go. 5 kilograms is $17. If we trace up 5, this is where 17 is. And a good way to do this when you're actually working on an exam or a paper or a question is to actually plot it onto your paper. So let's have a look. That's 20, that's 10, that would be about 15, that's 17. You could also go 15 is over here, and this would be, oh, that's a very shaky line. That would be 31. Very good way, that's how I do it, is to draw my 2 lines. So when we're thinking about linear relationships, we've just talked about our straight line relationships, our straight line graphs for linear relationships. What do we now mean by the terms gradient and slope? So the steeper the slope, the larger the gradient. Let's first start by talking about what a slope is. A slope is a vertical rise. So on this triangle, this is the slope. You can also think of slope as where you could pop some stairs or a ramp. It's the edge that goes up or down. So if I were to draw a triangle like this would be the slope. If I were to draw something like this would be the slope. If I were to have a triangle like this, first of all, we wouldn't use that for this unit, but we would have 2 slopes. Let me remove all of that. Okay, so the steeper the slope, the larger the gradient. When we talk about the gradient, we talk about the rise, which is how high our slope goes, and the run, how far it runs along the bottom. Our gradient is rise over run. Let's say this triangle was labeled 4 centimeters and 2 centimeters. To find the gradient, we would do 4 over 2, and that equals 2. Therefore, our gradient is simply represented as 2. The only other thing about this triangle is that this is actually a negative gradient. Gradients can run positive this way, or they can run negative this way, and this is a negative gradient. So for example, what is the gradient of this triangle? We have our rise, and we have our run. To do our gradient, we do our rise over our run, which would be 7 over 4. Now you can represent gradients as fractions. That's fine. It's actually a great way to do it a lot of the time. I do like to check if my fraction goes down to anything that's easier. This one goes down to 1.75. You could represent gradient as that. The only problem would be that these are both incorrect. It's either negative 7 over 4 or negative 1.75 because the gradient is running down. So as you can see here, this would be incorrect, negative 1.5. When we talk about graphs, as I've said, positive gradient, negative gradient. Positive, think of it as like running up the hill from the left. Negative gradient, think of it as like rolling down the hill from the top left. It's very, very important you remember this distinction. This is why a lot of students get their questions wrong. They forget to label positive and negative gradients. Furthermore, so we've got a gradient, we've got a straight line. We now have a vertical intercept. We also call this the y-intercept. This is where the line goes through the y-axis. It's going to be called in most problems the y-intercept. And unfortunately, when you see the straight line formula or the linear form, it's going to be represented by C. Why? Because maths likes to do things that aren't very nice sometimes. It's going to be C or it's going to be. It's not Y. The y-intercept is not represented by Y. For this question, the y-intercept would be 1, as that is the number that the line runs through on the y-intercept. Apologies. Okay, so your turn. What are the vertical intercepts of the two graphs below? Firstly, what number is this one running through? If we have a look, it's running through, I'll give you a sec, 3. So the y-intercept here is 3. And if we have a look here, the y-intercept is negative 5. 3 and negative 5. So as I was just saying, we have this linear form, y equals mx plus c. So this is the equation that we use to represent our straight line or linear graphs. It's got 4 different numbers that you need to remember. It's very important, or letters, sorry. It's very important that you know what these letters represent. If you don't, you are likely to get your questions very, very, very wrong. So we have y, m, x, and c. What do these represent? Y is the dependent variable. Think back to our old example, the cost of the coffee beans. So on our graph, if we were to have a graph like this, the dependent variable is this one. That's what's going here. M is the gradient of the line. Remember, this is rise over run. X is the independent variable. This is the weight of the coffee beans. This is what goes on the horizontal independent variable, the HIV, the horizontal. And C is the y-intercept. Remember, this is where our line intercepts with our dependent variable on our vertical axis. So we're going to do an example based on one of the graphs we've already looked at. We can use the info that was given to us in the graph to fill in the formula. So we have y equals mx plus c. We know that we need to place our y-intercept in. Let's have a look at our graph. 1 is where the positive 1 is where the line runs through. Therefore, c is positive 1. We also have a gradient, which we can measure by doing rise over run. So how do we find that based on just a line? We need to pick 2 separate points. So let's draw a triangle on to our line, firstly. The rise here is 1 to 5, which is going to be a rise of 4. Not 5, but 1, 2, 3, 4. We then have a run of 2. So we're going to do 2. 4 over 2 is going to be 2. Therefore, our gradient is 2, and it's a positive gradient. Now, we don't put in any values for y and x. Those can then be subbed in if we want to find other answers. But this is the full linear form. You only need to be putting in your intercept in C, your y-intercept, and your gradient in M. Okay, so now we're going to fill in this formula. for this graph, positive and negative gradients. Okay, I'm going to work slowly so you can do it at the same time. First, let's write out our form. Y equals mx plus c. A little caveat, sometimes you'll see the c is represented as b instead. This is the same thing. Okay, so first things first, I'm going to look for my y-intercept first. Y equals mx plus something. I'm going to look through. Where do we cross the line? We cross it here, which looks like it is 3. Y equals mx plus 3. Now I'm going to find my gradient. I'm going to do this by finding 2 points on the line that are very easy to coordinate. So let's take this one and this one. Let's make this our triangle. See how I wouldn't want to pick a point like this because it's not actually on the line, or a point like this because again, it's hovering through. This is the easiest points to pick. So first things first, what is the rise? We go from -3 to -2, -2 to -1, -1 to 0. Our rise is 3 and our run is 1, 2. Therefore, our gradient is, and is it a positive or a negative? It's a negative, -3/2, and this negative is for the whole fraction, x plus 3. Now, it's important that I make a point here. Just because these squares were 3 and 2, it doesn't mean it's always going to be that way. If this was 20 and 40, this would instead be, if we had a gradient that ran from, let's say, here to here, it would instead be, this is a rise of 20 over a run of 2. So it's important, you're counting the actual numbers, not the squares that you cross over. So if we, -1.5 is the same. So if we do 3/2, we get -1.5. So we can represent it as -1.5x or -3/2x plus 3. Either answer is correct. Okay, so this is a little bit more complicated. This is called direct variation relationships. So this is something that you encounter in year 11, you probably don't understand, you move to year 12, you still don't understand. It's something I really, really want you to get your head around now. It's a lot simpler once you understand it. This is essentially a relationship between two things where they depend on each other and they change depending on each other. So for example, we have the cost of fuel and how much fuel someone buys. Person's wage, the number of hours they work. It's the same principle as dependent and independent variables. So if y over k is a constant, we say y varies directly as x. That sentence doesn't make sense out of context. Essentially what we're saying is we have y and we have x. This is the amount of fuel someone bought. This is how much money they paid. We then have a constant, which we use, pretend that constant is spelt like this. That's how I think of it. Constant with a K. We then have a constant. The constant is the reason for this relationship. So if I bought $20 of fuel for $40, 20 liters of fuel for $40, there's got to be a constant. The constant is how many liters I can purchase for $1. There's a relationship here. We didn't just happen to spend $40. There was a constant that precluded the fact that we would spend $40 for 20 liters. So we have an equation to work it out. We usually do y over x equals k or y equals kx. So let's go through an example. A car is traveling at a constant speed of 60 kilometers an hour, and we're going to refer to this as its distance. The car will travel over multiple hours, which we're going to call time or t. Write an equation that represents the relationship between time and distance. So 60 kilometers an hour, which is the distance traveled, equals 60 times the number of hours. So we're going to show this as distance equals 60 times t. So our constant is going to be, in this case, 60. So here's your turn. A packet of chips will cost $4.50. Create a direct variation relationship that represents the cost of buying multiple bags of chips. Okay, so we have y equals x, y over x equals k, or y equals k over x. So the first thing I'm going to do is pick out that I have $4.50 bags of chips. N is the number of bags, and we'll call the cost C. How are we going to find the constant? We can do y. Let's make that that's our dependent. So our number of bags, and our cost is $4.50. We want to find our K. So I'll show you how we do that here. Oh, my working out hasn't loaded. We have our cost $4.50. Sorry, we want to work out our cost. We simply need to do $4.50 times by N. That's all we need to do for that direct variation relationship. We don't actually need to determine the constant. We just need to place our figures into a relationship to show how we would work it out. Now this is where we get into that's direct variation. This is proportionality. If y and x are proportional to one another, and we say y is 16 when x is 20.5, we have 4 questions we're going to answer here. So firstly, the constant of variation. If I go back here, we have y equals k over x. Y equals k over x. So for question A, y is 16. I want to find the constant, 20.5, constant over x. So how am I going to do that? I'm going to times each side by 20.5. 16 times 20.5 gives me 328. Therefore, my constant is 328. We can also check this in y over x equals k, which is probably going to give us a different answer and is something that I would probably say, well, this is our constant before we divide it. So let's do that one as well. Y over x equals k. So if we take y, 16 over 20.5, we should get k, which 16 over 20.5, we get 0.78, which is far more accurate. Let's ignore our first one. We have the equation connecting x and y. So if we're going to connect x and y, we can do x times our constant, which was 0.78, is going to equal y. Y when x is 32. When x is 32, we're going to do 32 times 0.78. 32 times 0.78, and we get 24.96. And x when y is 7.6. We're now going to substitute in. We want x times 0.78. We know that y is 7.6. So now we're going to divide that side by 7.6. 7.6 divided by 0.78. And we get that x is, oh, that doesn't look right. Hold on. Now I'm second guessing my own answer. I think I've popped on the next slide. Okay, yeah, here we go. The constant of variation, as I said, 0.78, and we've worked that out by doing what we said before. We then have the equation connecting, so we do y equals x over 0.78. Then we do what we did before, which is y equals 32 times 0.78. We got 24.96. And yeah, that's why my answer looks wrong. 7.6 equals x over 0.78. So you've got to pay attention. I've even messed this up in the past, of your times or your divide. So we get 9.74, which is what I got originally, and then second guess myself. Okay, beautiful. Another practice question. The amount of petrol that a car will use is directly proportional to the distance that it travels. A, if the car uses 8 litres of petrol to travel 60 kilometres, what is the constant of variation? So if we have 8 litres of petrol to travel 60 kilometres, we're going to do 60 divided by 8 litres. You could also do it the other way. Divided by 8 is going to be 7.5 liters per kilometer. So we can represent our constant as 7.5. How much petrol does the car use if it travels 190 kilometers? We can also divide this by, 7.5 kilometers per liter. I wrote that the wrong way around. Hang on, let me make that clearer for you. .5 kilometers per liter. If we want to drive 190 kilometers, we can do 190 divided by 7.5, and that will tell us how many liters we use. 190 divided by 7.5 gives me 25.33. I'm going to use 25.33 liters. How far can the car travel if it has 22 liters of petrol? We're going to travel 7.5 kilometers per liter. 7.5 times 22. 7.5 times 22 is 165 kilometers. Let's have a look at our answers. We have 7.5 is our constant, 190 divided by 7.5, 25.3, and 22 times 7.5 is 165 kilometers. All right, that is our algebra, our linear relationships section all finished up. That's one of our 4 sections. We're now going to jump into financial maths, and we're going to look at budgeting and household expenses. Okay, so this is just to show you your syllabus outcomes, because I think these things can be a little bit hard to imagine in context. When we're talking about our unit here, this is probably one of the most practical units that you're going to be taught. You're taught about bills, electricity, water, gas usage. You're taught about vehicle costs, which include on-road costs, sale price, registration, insurance, and stamp duty. You're also taught about sustainability, which is usually about fuel consumption rates, the cost of purchasing different vehicles using a spreadsheet. We also then look at the types of insurance we buy, and in compulsory, non-compulsory, third party, and comprehensive. We talk about running costs, and we also talk about budgets. You probably do a task, if you haven't already done it, I know a lot of my students have, where you get a task that's basically a take home on buying a car. If you didn't, that's perfectly fine. Not every school does it, but I know some students, and I did this in high school, did a whole kind of pretend task where you have to go on car sales, pick out a car, buy it, and it gives you really good insight into what it's like to have to purchase a car. I know that when I purchased my car, this stuff came in really handy for me, because I actually understood what the different payments were, what the insurance cost was, even though the insurance hurts every time it comes in, why I had to get a green slip, why I buy the insurance I buy, and why I spend the money I do on servicing my car. It's very, very valuable stuff. Okay, so like I said, it's all about the real life application of maths. They're very, very useful in the future. I would actually say this and the tax unit are the units that I kind of think about the most in my life. Like recently, just a little anecdote with the tax unit, I was investing some money in a different savings account, and I used my understanding of compound interest to help me pick the savings account that was going to give me the highest yield. So highly recommend some of these units in helping you in your life. Genuinely. I know that we always kind of ask those questions of like, when am I going to use this? But with this part of maths, I do actually think that these things are valuable. So budgeting and household expenses, household bills. So one of the skills that you'll need to develop is being able to read a household bill. This is something that probably does not come super intuitively. Maybe you've seen them lying around growing up. But they basically have 5 things that I'm going to explain to you now. Obviously, there's a little more than that, but there's about 5 that we're going to run through today that you need to understand. The first thing is a usage charge. This is the charge that you are paying based on the amount of the resource that you've used. So it's essentially how much money you're going to pay for the amount of water that you used. We then have a service charge. This is the charge just for using the company's service. If they didn't make this charge, you would essentially be paying the exact amount of money that they've spent to give you that water. So they have to make a little bit of a profit. That's capitalism. They need to make some profit. to pay their workers to run the business. So there's a service charge. We then have a peak rate. This is the rate for use at a peak time. We then have a shoulder rate. This is a rate for use not during a peak time. And then we have a supply period. This is the period of time in which usage occurs. So purchasing a car. This is something that many people begin to consider in their late teens, early 20s. It's definitely not something you have to do, but it's definitely something that I think is valuable. So first thing, when you go to buy a car, you either have the money or you don't have the money. Simple as that. You've either saved the money or you need to get a loan. If you can just use savings, that is the best way to buy a car. That is the easiest way because you're not paying anyone else. The money is literally just, if your car costs $12,000, it is $12,000 from your savings into the car. If you need to take out a loan, you aren't just taking out a loan. You have to pay interest back on that loan. So when you're purchasing a car, you need to consider this interest in the cost. Ignore the from a few weeks ago. We're going to use this table in our practice today. The following table shows the monthly repayments for every $1,000 borrowed on a reducing balance car loan. So let's think about Sally. Sally wants to purchase a car, but she doesn't have the money in her savings. So she's going to take out a loan of $18,000 to afford it. Over 24 months, she's going to pay it back at 9% per annum. So we're going to use our table to find the answer. She's going to pay the loan for 24 months, 9% per annum. It's going to be $45.68 for every $1,000 that she has spent in that loan. So she spent $18,000 times 45.68, which means that the interest or the monthly repayment, is $822.24. So though she wants to take out an $18,000 loan, if we times 822.24 times 24 months, she's actually paying back $19,733.76. So the bank is going to get $1,733.76 more than what they gave her because there needs to be an incentive to pay back a loan. The longer you take to pay back a loan, the more interest you pay. Let's talk about rego or registration. This is the fee that we use to transfer the registration from one owner to another. So if you buy a car from a dealership, you need to pay a registration to register the car to your name. If you're buying it privately from another person, it's just $32. This registration fee always depends on two things: the weight of the vehicle, without anything on it, so we call that tear weight, and whether the vehicle is being used for private or business purposes. So this is what that table looks like. This is at the RMS website. We have our tear weight, our private use fee, and our business use fee. So Ryan is registering a vehicle. It has a tear weight of 1,040 kilograms and is intended for private use. What is the cost of registration? He's going to fall within this bracket. It's private use, therefore it's going to be $254. Insurance. So in order to own a vehicle in New South Wales, you must have a green slip. This is your compulsory third-party insurance. If you've ever heard a green slip, not a pink slip, but a green slip, if you've heard your parents trying to shop around for the cheapest green slip, this is something that you need to have in order to drive your car. If you injure or kill another person in an accident, CTP covers this. Compulsory, in the name, you have to have it. Third party, it's going to cover what happens to the other person. It's not going to help you if you damage their car, which you're probably going to do. Not you. I'm saying if you get in an accident, you're probably not just going to injure the person, you're probably going to damage their vehicle. It doesn't cover the damage to their property. It doesn't cover vehicle theft for them, not for them. It doesn't cover, theft of your vehicle or of thefts, but of out of your vehicle. So if someone steals your bags. So in short, compulsory third party is just covering the insurance payable when you hit or kill or injure a person in an accident. It's not going to cover anything else. This is the insurance you have to have. In questions, you'll always be told what the cost of this CTP will be. You don't have to work it out. Comprehensive insurance is insurance you can get, which a lot of people do, and it covers damage to and theft of your vehicle as well as damage to other vehicles and property. So if you crash into someone when you have CTP and comprehensive, It's going to cover their medical bills and the damage that you've done to their car. Third-party property damage also covers damage to other people's vehicles and property. So you can also get third-party property damage. They kind of overlap, depends what you want to buy. Stamp duty. Stamp duty is a state tax. This is something charged by the government, and it's based on the market value of a vehicle or the price paid for it. Essentially, like the GST that we pay on goods, you're paying a stamp duty on buying a car. So according to the RTA, we have two different valuations of stamp duty. For most vehicles, so for any vehicle under $45,000, it's going to be $3 per every 100 of the vehicle's value. So if you have a $10,000 car, stamp duty is going to be $300. Now, if you have a 9-seater vehicle over $45,000, it's then going to be $5 per 100 for all the money over $45,000 plus $1,350. This is the stamp duty payable. Pardon me, guys. I'm getting to the depths of uni term. It's killing me. I'm kidding. Uni's not that bad. It's just this week. Anyway, the $1,350 is what you would pay if you had a vehicle that was $45,000 or less, or $45,000 capped. So it's basically saying all the money up until 45, plus we're going to add extra for it being over $45,000. So if you had a vehicle that costs $50,000, you would do $5,000, which is the difference between $50,000 and $45,000, times 0.05, which is 5%, which is going to equal, that's going to be $50, I think. Hold on. No. $250. Hold on. $5 per every $100. I'm guessing my own working out again. 0.05 times... No, $250 is correct. So we have $250 plus $1,350. Therefore, our stamp duty would be $1,600. So Rebecca must pay the stamp duty on her car, which costs $29,000. Calculate the stamp duty. All we need to do here is 29,000 times 0.03, which is 3 for every $100. So 3 over 100, 3%, or 0.03. I would recommend doing it this way. And that's going to be $870. Okay, suitability. We need to talk about depreciation. So cast your mind back to when you've learned about depreciation. Cars are one of the most common assets valuable to depreciation. So we want to factor that in when we decide whether it's suitable to purchase a specific vehicle or not. So if you're asked to calculate the book value, this is the value after depreciation, we need to remember the formula, which is salvage price equals purchase price minus the amount of depreciation times the number of time periods. This is the straight line depreciation. So if we quickly use an example for this, let's say that our car cost $17,000. It is depreciating by, and we're going to pop brackets here, $400 every year for 3 years. So I'm going to do $17,000 minus 400 times 3. And it's going to be worth, our salvage price is going to be $15,800 after 3 years. Very important stuff to remember. Okay, we also have fuel consumption. The suitability of purchasing a car is based on its fuel consumption. We can call this FC, basically how much fuel it needs to travel a certain distance. Now we can calculate this in 3 ways. Number 1, we can look at the fuel consumption in kilometers per liters, distance traveled kilometers divided by amount of fuel used, which is liters. We can also look at this in fuel kilometers of liters per kilometers, so amount of fuel used in liters divided by the distance traveled in kilometers. And we can finally look at this in fuel consumption is litres over 100 kilometres. So the amount of fuel we use per 100 kilometres, which we do by taking the amount of fuel used divided by the distance travelled and timesing it by 100. So essentially you just times that second formula by 100. So when we need to change the subject, we want to find the distance travelled. We can then do distance travelled equals amount of fuel used over our fuel consumption times 100. The lower the fuel consumption, the more affordable the car is. If the fuel consumption is 13 kilometers per litre, that's a way better consumption than 6 kilometers per litre. We also have servicing, repairs, and tyres. At certain time intervals, your car needs money spent on it. Just as we need to go to the doctor, our car does too. We need to give it basic physical checks, repairs. Your tyres are replaced every couple of years. A good way of thinking about this, which is what I do, based on being raised by my dad, who took me to the tyre shop with him every time he did it, is when you replace your tyres, you move the front ones to the back and you put new ones on the front. So you're not always replacing all four, and tyres only get replaced every couple of years. But these are costs that you have to consider. When I bought my car, it wasn't just the, 11 something thousand that I spent on it. It's also the insurance, the tyres, the repairs, the servicing, the petrol. It's all of these things. You will be told what most of them cost in the question. So to recap, standing cost, this is the cost that you basically take on the second that you purchase the car. You're considering the depreciation. My car is worth less now than it was when I bought it. The interest if you have a loan, on-road costs like your rego and your green slip, and insurance. And these are what we call operating costs. These are ones that go away when you sell the car, as all of them do, but they depend on how you use the car. We have our fuel. We want to think of our fuel consumption here in considering the best car to purchase, servicing, repairs, and tires. All right, budgeting. This is another point of the unit. It simply refers to planning financially for the future. It also includes you considering income and expenses. In the simplest sense, money is divided up into fixed spending. We have rent and food, and then discretionary spending such as entertainment and retail and savings. If you are looking for a way to budget, look up Atano's budgeting and income and expenses tracker, and about 2.5 years ago, we published an article that I wrote about this. I still use that same tracker. If you want to have a way to track your budgeting expenses, look that up. It's a great habit to get into quite young. All right, so here's a practice question. Hannah takes out a loan for a car payment of $26,000. She will repay it over 36 months. It has an interest rate of 10% per annum. We want to find the monthly repayments. Now, for this question, we don't have as you can see, we have an answer here. We don't have the table, so we can use our table from this question to answer that. So it was a 36-month loan, 10% per annum. So our value is 32.27. So we're going to do 32.27, and it was 26,000. So we're going to times by 26. 32.27 times 26 is $839.02. And our total interest, we need to find the total amount of money that we're going to spend on repaying the loan. So $839.02 times the number of months, which is 36 months, which gives us $30,204.72. And we then need to subtract the amount of money that the loan initially was for. So subtract 26,000, and the bank has charged Hannah $4,204.72 of interest. This is the money that she paid in addition to the loan. She would not have paid that if she just had the money in her savings. And we have that there as well, $839.02 and $4,204.72. Two cars travel 300 kilometers. One uses 33 liters, the other uses 45 liters. Show their fuel consumption rates. For car number one, we can do 33 liters divided by 300 kilometers. Or actually, we can do it the other way around. It's probably the easier way. Yeah, we can do 300, let me erase that and make it easy for you. We can do 300 over 33, and this equals 9.09. So this car is traveling 9.09 kilometers every liter. And this car, if we do 300 over 45, is traveling 6.6 kilometers every liter. So this car, number 2, its fuel consumption is worse. The fuel for car 1 costs $1.23 per litre. The fuel for car 2 costs 88 cents per litre. Those were the days. Which car is cheaper to drive? So let's calculate how much that 33 litres would have cost. $1.23 times 33 litres equals $40.59. And for car number 2, we have 88 cents, which is part of $1, times 45 litres, 0.88 times 45, we get 39.6. So this one you're going to have to fill out more, but car 2 is cheaper overall. $39.60, $40.59. And we have those represented in different forms as well. So you have 11 litres per 100 kilometres or 15 litres per 100 kilometres, and then we can also work it out this way. Therefore, we still have the same answer that car 2 is cheaper to drive. Okay, that brings us to the second content block. We are about an hour in, and we're now going to switch over to our statistics questions. So we're going to start off by looking at summary statistics. I have the, that's annoying. Ignore the bottom. We're not on statistics 2. We're on statistics 1, but it's stuffed up. There we go. We're going to look at our syllabus outcomes first. We have describe the distinguishing features of a population and a sample. Population values, we have mean, standard deviation, mean, and sample standard deviation. We have mode, mean, mode, and median. I don't want you guys to forget about those. They are very important. Central tendency, those are the words we use to describe mean, median, and mode. We have measures of spread, including the range, quantiles, quartiles, deciles, percentiles, IQR, standard deviation, and then we have our calculations for standard deviation that all happen on our calculator. We then talk about outliers, looking at Q1 and Q3 and our IQR. We also look at real-world examples. We talk about modality, unimodal, bimodal, or multimodal graphs. Shape, they can be symmetric, positively or negatively skewed. Central tendency, spread, and outliers using and justifying appropriate criteria. Box plots, 5-number summaries, central tendency and outliers being comparison measures, and the differences between parallel box plots in the context of data. Okay, that was a lot of words. We're going to start off by looking at populations and samples. They are groups from which we collect data that we have already learnt, hopefully, to classify and represent. We're going to look at the notations, and we call these measures of central tendency. The first is the mean. The mean is the average or the sum of all of the scores divided by the number of scores. So what is the mean of 5, 7, 12, 3, 11, 9, and 14? To work this out, we're going to add all of our numbers together. 5 plus 7 plus 12 plus 3 plus 11 plus 9 plus 14 gives me 61. And I need to divide that by the number of numbers. 1, 2, 3, 4, 5, 6, 7. 61 divided by 7 gives me 8.71, which we have there. The second is mode. The mode is the score that occurs most often. It's also called the most popular score. A set of scores can be bimodal or multimodal. There can be multiple modes. What is the mode of 8, 8, 5, 3, 4, 6, 2, 8? The mode there is obviously going to be 8. Now, if there were also 2 other 5s and 2 other 3s, it would be multimodal. The third is the median. The median is the middle score. This is once the scores have been arranged in ascending order from smallest to largest. What is the median of the following scores? 5, 8, 10, 9, 4, 3, 7. We're going to order them first. 3, 4, 5, 7, 8, 9, 10. The median or the middle score is going to be 7. Okay, standard deviation. This is determined by calculating the distance of each score from the mean and then calculating an average of these distances. The smaller the standard deviation, the closer all of the scores are to the mean or median. Standard deviation is kind of hard to understand, to be honest, at the outset, and it's something that you need to do quite a bit of work on in year 12 as well. So if you don't quite understand it just yet, that's okay. If you've learned about it in class and it's not really making sense, hopefully it will with a little bit more explanation today. Okay, just trying to find where I am in my slides. There we go. Okay, range. Range refers to the difference between the highest score and the lowest score in a group of data. So the range, highest minus lowest. What is the range of the following data set? It's going to be 14 minus 3. 14 minus 3 is 11. Very important that we don't always just skim out data. We might have thought, oh, 5 is our lowest score, but we had a sneaky 3 hiding in the middle. IQR, interquartile range, is the quartile range between Q1 and Q3. So we can divide all data into, it's 4 quartiles, but we're thinking about Q1, Q2, and Q3 when we label them. But it's 4 quartiles. We have the lower quartile, the middle quartile, and the upper quartile. We use these are our 3 numbers, but really data exists on this side and on this side as well. The lower quartile is Q1, the middle is Q2, the middle Q2 is always the median as well, and Q3. IQR, which is the interquartile range, not the full range, but the interquartile range, is going to be Q3 minus Q1. So if Q3 was 45 and Q1 was 16, our interquartile range would be 45 minus 16, which is 29. Find Q1, Q2, Q3, and the IQR for this data set. So first things first, we're going to separate our data out. We have 1, 3, 4, 5, 9, 10, and 12. We definitely have a median. This is our Q2. We then have Q1, which is 3, and 10, which is Q3. Q3, Q2. We want an IQR, so we're going to do 10 minus 3 equals 7. We can see under there 3, 5, 10, and our IQR is 7. So how does this then translate into a box plot or something else like that? We'll look at that in a minute. But it's very important that we first understand these 3 numbers in creating our 5-number summary, which we'll get to the other 2 numbers in a second. So some general rules: 25% of scores are less than Q1 and 75% are greater than Q1. So let's think again about where all our data is. Q1, Q2, Q3. This is 50% of all scores. This is 25%. This is 25%. And this can be split into 25 and 25 as well. So if 25% of scores are less than Q1, 75% are greater. 50% of scores are less than Q2, 50% are greater. 75% of scores are less than Q3, 25% are greater. So therefore the IQR, the interquartile range, is going to contain 50% of all the scores. The IQR is giving an indication of the spread of the scores from the median. So the greater the value, the greater the spread. It's usually not affected by outliers. On that question, what is an outlier? Outliers are scores that lie outside of the expected spread of the data. So what would be the outliers in the following data set? 1, 16, 22, 17, 19, 21, 23, and 34. So 1 and 34 are probably going to be our outliers. We think, right? We now need to figure out if they're mathematical outliers. We have 2 formulas here. Let's start by ordering our data. 1, 16, 17, 19, 21, 22, 23, and 24. We have our, let's see, our Q2 is going to be right in the middle. It's between 19 and 21, so it's going to be 20. Our Q1 is going to be 16.5, and our Q2 is going to be 22.5. Yes, you can go in between the numbers when you don't have the right number. To find our low range outlier, we're going to do 16.5 Q1 minus 1.5 times our interquartile range. Our interquartile range is 22.5 minus 16.5, which is 6. Once we do 16.5 minus 1.5 times 6, we get told that our low range outlier is going to be 7.5 or lower. Our high range outlier is going to be 22.5 plus 1.5 times our IQR. 22.5 plus 1.5 times 6 is 31.5. So a high range outlier is going to be 31.5 or higher. Therefore, we know if we've done those formulas correctly, 1 is an outlier as it's lower than 7.5, 34 is an outlier as it's higher than 31.5. Those formulas are not given to you. Oh, actually, I have my formula sheet somewhere here. I can't remember off the top of my head whether those are on your reference sheet in the HSC. Oh, hang on, here it is. Yes, they are. So I don't think you can see this, but in the statistical analysis section in the HSC, they do give you those formulas. Okay, so real world applications. We're going to have a look at how central tendency measures, mean, mode, median, IQR, Q1, Q2, Q3, all of that. How do these exist in the real world? They can actually be used to identify real data trends. We can think of that as poverty, financial growth, disease spread, birth rates, and more. These are 3 examples. On the first one, we have number of deaths involving COVID. This shows measures of central tendency in regard to, we have our dependent variable here, which is the number of deaths that we can determine based on, they're determined on the number on the day, but we can use things like our mode to find the most common number of deaths. Now, this is a cumulative graph, so you can't exactly do it on this, but this shows how those are used. This is a world population living in extreme poverty. Again, we can see that this demonstrates we've got people in extreme poverty and not in extreme poverty, and we can again use things like our measures of central tendency to determine certain patterns of growth, or as we'd like to see, decay. Women are also having fewer children. This is a graph that shows global fertility rate, and again, we can use our measures of central tendency here. Okay, so what do we notice about these graphs? How could we misuse measures of central tendency? I want you to pop in the chat something that could be a misuse of central tendency. What could be a way that we misuse one of those measures? As you pop those in the chat, I will let you know whether you are incorrect or correct. Okay, so a couple of things about our graphical data displays. Firstly, relative frequency and probability. There are 2 ways that this can appear. It can be smooth or it can be not smooth. It's very important that you can identify the difference between these 2. Smooth generally indicates a closer formation of data. Maybe our data looks something like this. Whereas smooth, not smooth is going to be something like this, which is not exactly uniform data. We also have unimodal and bimodal. This is when we have a data set like this, where we have one clear mode. Bimodal would be a data set like this, where we have 2 modes. We also have multimodal, which would be if we had, say the mode was 3, 5, and 7, and there was 3 of each of those numbers. We also have positively skewed versus negatively skewed. So our data exists in a positive manner or in a negative manner. Positively skewed data, it's very important. The hump is at the beginning. It's on the left-hand side of the data. Negatively skewed data, the hump is on the right-hand side. Now think of it as trying to escape from your gradient, because if you're thinking gradients, this would be a negative gradient and this would be a positive gradient. You need to not think about that. You need to think about positive is the hump at the beginning, negative is the hump at the back. All right, we're going to talk about box plots now. Box plots are super useful. I think they're kind of a fun way as well to represent data. So to make them, we need to learn how to find a 5-number summary. We've already learned about 3 of these numbers. This is Q1, Q2, and Q3. Does anybody want to write in the chat, what is the difference between Q1 and Q3? What is the 3-letter acronym that we are using to represent the difference between the lower and upper quartile? Pop that in the chat. I'll let you know if you're right. Okay, so we have, in addition to Q1, Q2, and Q3, we have our minimum value and we have our maximum value. These are very simply just taken from the numbers. So this is what our 5-number summary looks like. I'd recommend writing this down on a summary sheet. Number 1 is the lowest score. This can be an outlier. Number 2 is the lower quartile, which is Q1. Number 3 is the median, which is Q2. Number 4 is the upper quartile, which is Q3. And number 5 is the highest score. This also could be an outlier. So for example, we're going to find the 5-number summary from the following data set. 35, 35, 36, 36, 37, 38, 39, 39, 39, and 40. First things first, I am going to always start from the middle. That's just the easiest way to work it out, in my opinion, is to start by figuring out Q2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, which means that there's not going to be a clear number here that we can circle. Instead, our Q2 is going to be 37.5. Next, we have our Q1, which is going to be the number halfway between Q2 and the base, or 35, which is going to be 36. Q3 is going to be 39. Our lowest score is going to be 35, and our highest score is going to be 40. Therefore, our 5-number summary is as follows. We can then also write this out in answering. If you were asked to answer, you would literally just write this out like this. If we check our answer, 35, 36, 37.5, 39, and 40. We can then use this 5-number summary to create a box plot. So we have our minimum value, lower quartile, median, upper quartile, and our maximum value. We're going to place those onto our box plot. Now ignore that the numbers are obviously not evenly spaced. This is just to show you how we build it. The first thing I do is draw my box between 36 and 39. We then place our Q2 line where we break down our data, which is 37.5. And then we break down our lowest number, which is 35, and our highest number, which is 40. It's important to remember that this is 25% of the data. This is 25%. This is 25%. And this is 25% of the data. Okay, relative frequency and probability. We're going to look at some practice questions. 2 different English classes sit the same exam. Their results of a score out of 20 are below. Class 1, we have 12, 12, 13, 13, 13, 14, 15, 17, 17, 17, 18, 19, 19, 20, and 20. And for class 2, we have 9, 10, 10, 12, 12, 12, 12, 14, 16, 16, 18, 18, 19, 20, and 20. Now we want to figure out first how many people were in each class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Great, so you have the same number in each class. Our 2 questions: create a 5-number summary for each data set and draw 2 box plots. I'd love for you guys to draw these box plots as we go. The first thing we're going to do is work out our 5-number summary. When we have 15 numbers, that means that there are 7 on one side, 7 on the other side, and the 8th number is the median, or Q2. So 1, 2, 3, 4, 5, 6, 7, 8. This is Q2. We then go back and we want to find Q1. There's 3 numbers on this side, 3 numbers on this side. This is Q1, and then this becomes Q3. We then need our lowest and our highest. This is our lowest, which is 12, our highest, which is 20. Therefore, for class number 1, and I'll draw it down here for you, we have 12, 13, 17, 19, and 20. We're now going to find our 5-number summary for class 2. Our middle number is, that's 4, 5, 6, 7, 14, which is Q2. Our Q1 is 12. Our Q3 is 18. Our lowest is 9. And our highest is 20. So for class 2, it's 9, 12, 14, 18, and 20. So just looking at this, which class has the better results? Probably class 1. As they have an average higher number for each of those 5 points. We can also look at their IQR. So the IQR for class 1 is going to be 19 minus 13, which is 6. The IQR for class 2 is 6 as well, 18 minus 12. So generally the IQR is pretty close. But again, the average range there for class 1 is a lot higher than for class 2. Okay, so now I need to draw 2 box plots. I will actually draw this on here for you guys to show you how I work through it. So first things first, I'm going to pop a number line on. We're going to start at 9. We're going to end at 20. And we will go 10. And then we'll go 12, 14, 16, 18, 20. Okay, so for class number 1, let's do class number 1 in green. Class number 1, we start at 12. We then have a line at 13. For our box, we have our median at 17. We have our Q3 at 19. And our highest is at 20. So our box plot for class 1 is going to look a little like that. For class 2, let's do class 2 in blue. We have this is kind of how I do it more, is I go 12, 14, 18, draw that on, pop our smallest in, 9, and our largest, which is 20. So what do we know about the classes? Let's label some stuff in purple. This is 25%, right? So 50% of the students in class 2 got below 14, whereas 50% of the students in class 1 got below 17. So obviously the average there is a lot higher for class number 1. We can also see that 50% of students got over 17, whereas 50% of students got over 14 for class 2. If we take a look at our answer, we can see exactly the same thing drawn on there. 12, 13, 17, 19, 20, 9, 12, 14, 18, and 20. And they are represented the same as we just did there. This is a better way to do it, obviously with a ruler and a nice pretty number line, because we have all the numbers there, but if need be, you can represent like this. Okay, create a 5-number summary for the following data sets: 5, 7, 9, 13, 14, 16, 16, 16, 18, and 20. For this first one, we have 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to go to the middle here. Now, if the number I guess we're using purple now. If the number can't be circled because there's an even number of numbers, then we write the number that falls halfway between them. If it's 16, 16, then the number's just 16. If it's 14, 16, the number's 15. If it was 14 and 15, it would be 14.5. We then circle our Q1, our Q3, and our lowest and our highest. I'm hoping you guys are working at a similar pace so you can kind of do it at the same time. Let's have a look at this one. Again, we do have our Q2, which is 34, 32, 37, 30, and 38. The smaller the range, the more that the numbers are going to be in the 5-number summary. 2, 2, 4, 7, 8, 11, 14, 19. Our middle number is going to be here, and it's going to be 7.5. We then have here, which is going to be 3, here, which is going to be 12.5, and then 2 and 19. The only numbers which you are guaranteed to be a part of the 5-number summary from the actual numbers are the lowest and the highest. Finally, 50, 54, 58, 63, 69, 72, 78. We have our Q2, which is in the middle here between 58 and 63. So it's going to be 60.5. Oh, no, sorry, ignore that. Hold on. I didn't count correctly. We have a number which we can just circle, 63. We then have our Q1, which is 54, our Q3, which is 72, our lowest, which is 50, and our highest, which is 78. And we can see all of that drawn on there as well. What's going on with that one at the bottom? Second guessing my own working again. This is actually probably more correct now that I'm reading it. As we can see, we've gone between the numbers just to be extra certain. So make sure that when you don't have that odd number that you can pull out from the middle, you go between the numbers. My mistake. All right, so before we start relative frequency and probability, pop a number in the chat, 1 being bad, 5 being good, as to how you're feeling about summary statistics that we just covered. Now we're doing relative frequency and probability. That's really annoying that my slides messed up and had the wrong topic on there. What we just did was summary statistics. Again, pop a 1 for not feeling great and a 5 for feeling okay about that content. I don't expect you guys to have fully grasped it. Obviously, I just kind of threw a bunch of stuff at you right there, but it's still something you're in the process of learning. So hopefully you're somewhere around that 3, 4, or 5 range. All right, relative frequency and probability. These are our syllabus outcomes. Review, understand, and use the language associated with theoretical probability and relative frequency. Construct a sample space for an experiment and use it to determine the number of outcomes. Review probability as a measure of the likely chance of occurrence of an event. Review the probability scale. 0 is less than or equal to the probability of an event, which is less than or equal to 1 for every event, with probability of an event equaling 0 if the event is impossible, and probability of the event equaling 1 if the event is certain. Determine the probabilities associated with simple games and experiments. Use the following definition of probability of an event where outcomes are equally likely. Event equals number of favorable outcomes over total number of outcomes, and the probability of the complement of an event. So, starting off simple, what is a sample space? Sample space, when we talk about experiments, is the set of all possible outcomes that an experiment can have. For example, what is the sample space of rolling a dice or a die? It's simply going to be rolling a 1, 2, 3, 4, 5, or 6. You are just spelling out what are all the possible things that can take place if this event happens. Determining the number of outcomes. It's super easy to do this. For rolling a regular die, there are simply 6 outcomes. However, if the experiment was to roll the die twice, there would be many more than 6 outcomes. Let's say the experiment was adding together the 2 numbers that you roll. Obviously, for the first roll, you're just going to get 1, 2, 3, 4, 5, or 6. But then you can get 1 plus 1, 2, 3, 4, 5, or 6. So that then turns into really what would be 36 different outcomes. For example, for the following experiments, determine the sample space and the number of outcomes. A, flipping a coin twice. We have the sample space is flipping it and getting heads or tails, which means that there are 2 outcomes the first time, and then we do heads or tails again, which means there are another 2 outcomes the second time. So essentially, if you think of it like this, we could do heads and then tails, and then tails and then heads. You could do heads and then heads, or you could do tails and then tails. So if you just attribute it to 2 different types that you can get, it's really just 2 outcomes each time. Or if you're adding together the 2 outcomes in order, then there are essentially 4 different outcomes that you can collect there. The face that a cube will land on if dropped, there are 6 sides, so it's going to land on side 1, side 2, side 3, side 4, side 5, or side 6. Choosing 2 colors from a list of 10, there are going to be from a list of 10 and you're choosing 2 colors, essentially you could choose one of 5 different options if you're combining the colors. So for flipping a coin twice, this is if we don't consider the order. So this could be tails, head. We have 3 outcomes. For the number of sides that for the face that a cube will land on if dropped, we have 6 sides, side 1, side 2, side 3, side 4, side 5, and side 6. There are 6 outcomes. And then this is where it gets more complicated, choosing 2 colors from a list of 10. If we have 10 colors and we're kind of considering what's already been chosen, we have 1 over 10. We then remove that first color that we picked and we have 1 over 9. So we end up with 90 different outcomes. This is kind of best represented this way. Think of these as all the different colors. Say you picked color 1. When you go to pick the second color, you can't pick color 1 anymore. So you would have to pick one of the other remaining 9 colors. Probability. Probability is the measure of how likely or unlikely it is that a certain event will take place. We measure this using a formula. Probability of the event equals number of favorable outcomes over total number of outcomes. So we can use a fraction, a decimal, or a percentage. Let's say that an event has 6 favorable outcomes and there are 36 total outcomes. The probability of that event is now 1 over 6. We could also represent 1 over 6 as a percentage, which would be 16%, or as a decimal, which would be 0.16. If an event is impossible, we represent it as 0. If it's certain, we represent it as 1. So all probability exists on a scale of 0 to 1. The probability of an event, so probability of an event, has to exist somewhere on this scale. It can't be more than 1 and it can't be less than 0. We also need to define these 2 other terms, relative frequency and theoretical probability. Relative frequency is the experimental probability. So relative to the actual experiment you do, it's an estimate of the probability of an event occurring. So we take frequency divided by the total number of possibilities. So for relative frequency of, again, let's take rolling a die, the probability of an event occurring, let's say rolling a 1 over the total number of possibilities, which is there's 6 options, our probability is going to be, for that experiment, 1 over 6. The theoretical probability is the mathematical probability when we consider all outcomes equally likely. For the dice example, it's the same. It's still 1 over 6. But if we kind of want to break it down to be a bit more simple, experimental or relative is your results. Theoretical is the probability in theory. Theoretically, what should you find when you conduct this experiment? You might roll a dice and you get 6 times in a row. Theoretically, you should only get it once of those 6 times. For example, what is the probability of the following events? A student is chosen from their class of 20. We have one student being chosen from a class of 20. The probability is just going to be 1 over 20. B, a 7 of hearts is selected from a deck of playing cards. Now, this is actually something you do need to know. There are 52 playing cards in a deck, 13 of each of the 4 different types. We have, I'll do them in their colors for you in case you get questions on this. We have hearts, diamonds, and then for the black cards, we have it's kind of like this. Spades. And we have clubs. That's the best that I can represent those. It is very important you actually know this, because you will get questions like, what is the chance of pulling a black card from a deck of cards? And you need to know that there are 52, half of them are black. A 7 of hearts being selected, there is only a 1 in 52 chance that happens. Buying 5 tickets in a 200 ticket raffle and winning, we had a 5 over 200 chance, but that's not the easiest way to represent this. Let's do 5 over 200 in our calculator. And really our probability was 1 over 40, or 0.025, which is 2.5%. We have that all listed off there. Okay, when we measure probability, we also assign words that measure said probability, as opposed to just using percentages, fractions, and decimals. This is an example of what that scale of words might look like. At 0%, we have impossible. If an event has a 0% chance of happening, it is literally impossible, figuratively, theoretically, and realistically. Unlikely is 25%. That's when something's quite unlikely to happen, but it's got a 25% chance. 50-50 is the word we use to describe something when it is 50% likely. So if I flip a coin, I'm 50% have a chance of getting a heads, 50% have a chance of getting a tails. Likely is 75%, and certain is 100%. For example, what is the probability of the following events happening? It rains on a Tuesday during a week in winter. I would probably give that one likely. There's no really scientific method to this. It's more of just understanding the usage of the words. You probably wouldn't say 50-50 because it doesn't really feel that unlikely, but you wouldn't say 100%. 3 coins all land on the same side. Well, there's actually two different sides that they can land on, and there's 3 different coins. So we could probably consider this as 25%. Or unlikely. There's a 50% chance that 2 of them land on the same side. So if you add on that third one, we're probably dropping down, we would think to 25%. But this is the caveat with this one. The probability is still actually 50%. Because for all of these, there is a 50% chance they land on heads, or a 50% chance they land on tails. 10 students all have the same eye color. We have probably I would go lower than 25%, but let's say 25%. I don't know. Brown eyes are very common. And this has changed for some reason to 5 students, but we've got likely, 50-50, and likely, and we can see 75%. 10 students I go unlikely, but 5 I could go likely. All right, probability scale. This is a mathematical scale that measures how probable any given event is. 0 is smaller than or equal to the probability of an event, which is smaller than or equal to 1. Probability of an event being 0, it's impossible. Probability of an event being 1, it is certain. These are very important distinctions to remember. For example, use the probability scale to represent the following events as either impossible or certain. A coin lands on either heads or tails. If we go to our probability scale, let's write it out. We have 0. A coin lands on either heads or tails. That is going to be 1. It rains every day of the year. Now, I would go with 0, to be honest with you. I don't see how that could be possible, in Australia at least. A baby is elected Prime Minister. Let's go with 0, but you never know. Those are what I would recommend for those answers. They're not usually going to give you questions like use the probability scale to represent, but rather you need to understand how the probability scale works so that if you do need to use it to support an answer, you can. Okay, let's talk about complementary events. Complementary events are events that oppose each other or are not the same. For example, flipping a coin will usually result in heads or tails, or does result in heads or tails, and these are 2 complementary events. So one cannot happen if the other one happens. You can't get heads and tails at the same time. I am yet to see that happen. So number of outcomes in E plus number of outcomes in E with a dash over it. E with a dash over it represents the complement or the other event. When you add those 2 together, you're going to get the total number of possible outcomes. So let's take this heads or tails example. Let's say the event is getting heads when you toss a coin or flip a coin, the number of outcomes is going to be 1 plus the other outcomes which can happen, which is getting tails, is only one other, which means there's 2 total possible outcomes. Let's take something like rolling a dice. Let's say you want to get a 5. That is one event that will happen. There are 5 other events that can happen, 1, 2, 3, 4, or 6, which means there are 6 total possible outcomes. For example, what are the complements of the following events? Rolling a 3 on a regular die. As we just said, there is 1, 3, and there are 5 other events, which equals 6. When we say what are the complements, though, we need to list out all the other options. So we could roll a 1, a 2, a 4, a 5, or a 6. Picking a clubs card from a deck. Now, there are 4 different types of cards in a deck: hearts, diamonds, spades, and clubs. There are 52 cards, and when we divide that by 4, we get 13 cards per suite, which is hearts, diamonds, clubs, and spades. Picking a clubs card, there are 13 of those. We know that there is a 1 in 4 chance. So our complements are picking a heart, that is a horrible heart, a diamond, or a spade. Oh my goodness, I refuse to leave that on the screen. Give me a sec. Again, that's actually not what a spade looks like at all, but it's like it's got a bit of a base going on here too. Something like that. Okay, so picking a clubs card, the complements are going to be picking a hearts, diamond, or spades. Picking a black pen out of a pot of black, blue, and red pens, the complement is going to be picking blue or red. And we've listed all of that out there. Okay, we've got some practice questions now. 2 cards are drawn from a standard deck of playing cards, 52 cards, with each card being reinserted in the deck after being chosen. The suit, not the number of the card, is noted. Find all possible outcomes of the multi-stage experiment. So 2 cards are drawn. Each card is reinserted in the deck after being chosen. The suite, not the number, is noted. So we just have the suite. So we can pick, and it's going to be kind of hard to represent, so I'm going to do it like this. We can pick 4 different cards: a heart, a club, a spade, or a diamond. Now, when I'm working out, this is literally how I work it out. We can do heart, diamond, spade, or club. Same here. For the second card, we can do a heart, a diamond, a spade, or a club. So you can list these out as option 1, option 2, option 3, option 4. Continuing on, you'd have 16 possible outcomes, and you would need to list them all as in the table. What is the probability that both cards are the same suit? That's 1, 2, 3, and 4. So there's going to be 4 over 16, which we can also write as 1 over 4. Probability that both of the cards are the same suit. What is the probability that they are both hearts? That is even smaller. We have 1 over 16 chance there. What is the probability that one of the cards is a club? We have 1, 2, 3, 4, 5, 6, 7. We have a 7 over 16 chance. Let's see if we can represent that any other way. 7 over 16. Nope, we'll leave it as that. If we have a look at our answer. We've listed out all of our outcomes here by representing them in there. So clubs, 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 diamond, clubs, heart, clubs, spades. We've written it out there. What is the probability that both cards are the same suit? 4 over 16, which is 1 over 4. What is the probability that they are both hearts? 1 over 16. What is the probability that one of the cards is a club? 7 over 16. All right, create a tree diagram. Now, this is something that I haven't taught you, but hopefully you've learnt before, that represents the following. 5 green marbles and 4 blue marbles are in a bag. 2 are chosen, each being replaced after being selected. So a tree diagram is a way that we can represent relative frequency and probability. So each are replaced after being selected. Let's make sure that's not already on there. All right, so a tree diagram represents these options. The first choice we have to make is our first marble. And we're going to label this as we'll go first here. When we pick out our first marble, it can either be green or it can be blue. There are only 2 options. There are 5 green and 4 blue, which means that there is a 5/9 chance that it's going to be green and a 4/9 chance that it's going to be blue. We have a second aspect of our question here, which is that we pick a second marble. And critically, it says that the marbles are replaced after being selected. So I'm going to show you how to do it that way, and then I'm going to show you what you would do if it didn't say that. We're then going to do our second 2 choices. We have a green marble that could be picked or a blue marble that could be picked. It's still a 5/9 chance of getting green or a 4/9 chance of picking a blue marble. Same options down here. We have a green marble could be picked or a blue marble could be picked. 5/9 chance for green, 4/9 chance for blue. To find the options, so say the question said, what is the chance of picking 2 green marbles? All you need to do is do 5/9 times 5/9. And you would get 0.3. So there is an 0.3 chance that you pick 2 greens. To pick a green and a blue would be 5/9 times 4/9, which is going to be 0.25. This is an 0.25 chance of this happening and an 0.25 chance of this happening. And then to pick a green and a blue and a blue, there would be an 0.19 chance of this happening. Let me double check that first one though, because we do want it to add up. Oh, 0.31. There we go. So this adds up to 25 plus 25 plus 31 plus 19. That does add up to 100. So that's how we would represent it if we had replacement. If the marbles weren't replaced, this would become, and I'll write it in red for you, 5/9 for the first green marble, and then if it weren't replaced, it would be 4/9. It would also be, for here, it would become 4/8 and 4/8. And this would become 3/8 and 5/8. So it's important, if we pay attention to this part of the question, if the marbles aren't replaced, that the number on both sides of the fraction goes down for the color that was picked in the previous set, and also for the total denominator for every number. That is how we build a tree diagram. So that brings us to the end of our 4 units. We still have about 15 or so minutes left. So what I'm going to do is run through some final tips that I have, but this is also the time for you to pop all of your questions into the chat. Firstly, what have we covered? There are 4 different units in Year 11. There is formulae, algebra, measurement, financial, and statistical analysis. Within that, there are 7 different units. So we have formulae and equations and linear relationships from algebra. Today we looked at linear relationships, which was our straight line, independent, dependent, y, x-axis, y equals mx plus b, or c, gradient, slope, all of that stuff. There's also measurement, applications of measurement, and working with time. We did not look at either of those today. We then have financial maths, which just has the unit money matters. We looked at car repayments, energy and household bills, budgeting and expenses. And we looked at statistical analysis, which is our 4th unit. We talked about data analysis, which was all of our summary statistics stuff that we went through to do with our measures of central tendency, box plots, 5-number summaries. And we talked about relative frequency and probability, which was our second part of the lecture, of that second half, which was all of our probability of event, our or 5 tree diagrams. Let's have a look. We just went through. All of our sample spaces, probability scale, measuring likelihood, etc. Okay, beautiful. So those are our 4 different units. I want to give you guys a little bit of context as you ask your questions in the chat as to where all of these land you next year. All of these continue with relatively similar aspects of the syllabus, except we add a unit called networks. So if you ever see this word, I don't want you to be scared. It's just that there is a 5th unit in year 12 called networks. All other 4 stay the same. These parts change, obviously. These go into practicalities of measurement, non-right angled trigonometry, non-linear relationships, linear relationships, compound interest. What else do we have? Our classifying and representing data expands as well. There's a bunch of new stuff in all of that. So you don't learn the same thing, but those 4 core topics plus networks are the same. Okay, so let me know in the chat while I talk, what are your biggest fears or concerns as you move through year 11? I am going to hit off on the big ones that I hear from students all the time while you let me know. So the first thing that I hear from students all the time is procrastination. As one of their kind of problems, concerns, something they really struggle with. I am a really big procrastinator. I procrastinate in pretty much everything, in things in my personal life, like paying a fee or buying a textbook or enrolling in my subjects. And I procrastinate in things to do with university, like writing assignments. I procrastinate sometimes in leaving the house, and it ends up me being late. I am a big procrastinator. It is something I'm still working on, but I do think I have a few tips if we talk about just academic procrastination. The first thing is trying to break your work into super achievable chunks. Now, this is not something that is easy to do. It's something you kind of understand how to do over time. The way that I do this is by not really breaking it into achievable, but breaking it into like minuscule chunks. I'll see if I can find an example in my notebook that I use when I'm working. Because when I say that I break down my work into tiny chunks, I mean tiny chunks. Let's see. Yeah, this is a good one. So here I was planning out an assessment I had to do for university. And I said that one of my tasks was just to read the assessment. The next thing was to read the post that my lecturer had put up on our forum. The next thing was to read another part of the assessment, which was a simulation. And then the next part, slightly less easy, was to find 25 sources. So sometimes those tasks are not super easy, but a lot of the times I literally break my work down into, and I'm not kidding, sometimes the dot point will be create document. Let's see if I've done that before in here. I'm not going to keep looking for it just to prove a point to you. But I genuinely break my work down. Yeah, here's one. This is a midterm. Read the problem question, create a document, read the forum, annotate the problem question. So I break my work down, even though that probably all up took me 20 minutes, I broke it down into 4 different tasks. And doing that makes my work seem really, really, really achievable, and not like I just have a point on my notebook that says start assessment, because that I am not going to do. But if you give me a task like creating a document, I'll just do it now. It takes 2 minutes. The second part of that is procrastinating on things that take a certain amount of time. So number 1, think about your procrastination as being able to break down things into tiny, tiny chunks. Secondly, if something is going to take you less than 5 minutes, make it a rule that you have to do it. This is something like folding washing, taking the bins out, or academically, something like writing an email, reading assessment feedback, printing your problem question, trying 3 multiple choice questions. There are so many things you can do in 5 minutes, and that really, really, really builds up over time. The third thing I would recommend is trying to counter whatever the mental block is for you in starting something. Often, the reason you procrastinate is simply because you don't want to do it. The way that you can get around this is by making a deal with yourself that you only have to do it for 5 minutes. You only have to work on your assessment for 5 minutes. At the worst, you did the assessment for 5 minutes. At the best, and this is what happens every single time I do this, I say, okay, you have to work on it for 5 minutes. And I start and I'm like, you know what? It's actually not that bad. I can probably just finish it now. I can just get started on it now. I'll just do half an hour. And then that half an hour turns into an hour. And suddenly all that time that I would have wasted procrastinating, I've actually done the assessment. So that's another point I'd really recommend, is think about the realistic block that is existing for you mentally. Is it just that you don't want to do it? In that case, just do it for 5 minutes. If you end up doing it longer, that's just an added benefit. The next thing I would say about procrastination, this is something I feel like I'm very well versed in, is thinking about what tools really help you in avoiding it. And I mean like actual tools, not like a screwdriver, but I'm saying things that are tangible and that you can use. I'm just trying to get it to load on my phone, but I use an app called Forest, which is an app that on your screen plants a tree. And if you get off the app or you do anything else on your phone, you can obviously close your phone, but if you do anything else, the tree dies. And I don't know why, but it works for me. So I think in my HSC year, I logged like 60 hours on that studying, and that was just times that I used it to get off of my phone. This all comes back to what is distracting you. For me, my phone's a big distractor. The internet is a big distractor. I just start Googling things. Another way that I get around that is I keep a sticky note next to me at all times, and everything that I want to do while I'm studying or trying to do something like Google like deepest part of the ocean, I write it down. And then I can Google all of this stuff later on, and I can look it up all later on, and I can enjoy myself. And often I don't anymore, because all it was a way to distract myself. Finally, if you are a big again, really distracted, and you don't study alone very well, kind of a niche thing, but I really recommend like looking up study YouTubers. So my personal favorites in high school were 3 girls, Eve Cornwell, Ruby Granger, and a girl called Unjaded Jade on YouTube. You can look all 3 of them up. But there's a bunch of people you can just look up. Study with me, study quiet with me, study with lo-fi music with me, and these people will exist on YouTube making videos, and you can study alongside them. And it uses a technique called body doubling, which is an kind of psychologically proved thing, which is that when we work with someone else, often in silence, it actually helps us stay focused. Another thing that I find a lot of students tell me when I ask them what their biggest concern is falling behind. On the screen now, I have a way that I like to think about focusing on assessments. It's not the easiest thing to do because it involves you being quite prepared, but preparation is the key to avoiding failure and obtaining success. So my recommendation is to try and finalize your notes about 4 weeks out from the assessment. About 3 weeks out, you want to be able to do the practice paper untimed, so you don't need to time yourself, and with your notes out. So give yourself free rein. Do whatever you want. Google. Have every opportunity to check your answers before you submit them. 2 weeks out, it's time to switch to timed conditions and to pop as much of those notes away. I would recommend as soon as possible just using your summary sheets. This is obviously the year 12 one, but in year 11 you can use your summary sheets. And then a week out, you really want to attempt the exam maybe twice in full exam conditions. Doing something timed is the reason that I think I did well in the HSC, to be honest with you. Obviously, academically, I did generally do quite well throughout school, but the fact that I practiced things in timed conditions meant that I finished every exam I ever did. And it's really, really important because that is going to gain you back so many marks. Just finishing the exam is putting you ahead of, honestly, like 50% of students easily. Another thing that I hear from a lot of students is about stress. I hear from a lot of students that they're really kind of scared of what they're going to go through and that it's going to be stressful. And to be honest with you, it is really stressful. Year 12 it's hard to explain. Year 12 for me was in 2020. It was simultaneously the worst and best year of my life. And I attribute the best aspects of it to the fact that year 12 is actually really enjoyable in a lot of ways. It's a really lovely bonding experience. You spend a lot of time with people that you love and that you respect and that you care for. And it's a great way it's a beautiful way to cap out high school as it is. Obviously, it is very stressful, and it was for me exacerbated by COVID and, personal things. And for you, I'm sure the same thing will happen, where there'll be things that come up that are hard to deal with and make year 12 a little bit of a struggle sometimes. But Year 11 and 12, I do think, are some of the best years of high school, the best years, and they don't have to be something to be afraid of. They're something to hopefully be enjoyed and to be treasured. And what I would say is the most important thing for you is to come out having proved something to yourself. It doesn't matter what you prove to other people. If proving something to yourself is proving that you can get a 65 ATAR, then you prove that, then congratulations. If it's proving to yourself that you can get into a certain course or you can just get through it. Honestly, the thing that I am most proud of is the fact that I got through year 11 and 12 rather than the fact that I got a 95.6. And I know that sounds like I'm lying, but due to my circumstances in year 11 and 12 and kind of what I was dealing with, the very fact that I got through year 11 and 12 is something that I'm very, very proud of, and I still regard as a bigger achievement than anything I've done in university since. Obviously, uni is great, but I think getting through year 12 was a bigger deal, to be honest with you, because uni is not as hard, and I stand by that. Doing a law degree, uni is not as hard as year 11 and 12 were. And that's not to say that year 11 and 12 are insanely hard, but it's just to say that they are quite hard compared to uni because you're going to school, 7 hours a day compared to 7 hours a week that I might do. Another thing I hear from students is issues with motivation. And motivation is definitely a very tricky one to balance. It's something that a lot of students lose very quickly. Number one, try and use the holidays as much as possible to take a break. The more of a break you take, the more you come back. Almost, I won't use the word excited because that's really going to feed into the teacher's pet rumor that I've started myself. But the more that you do in the holidays to take a break, the more motivated you come back to term and the more kind of ready you are to keep learning. And I find that in uni is that the better break I take during the holidays, the more I come back ready to start learning again. In terms of trying to avoid burnout, it's about not overloading yourself. The more that you overload yourself, the more inevitable that burnout becomes. And trust me, it will happen if you overload yourself. I burned out about 2 weeks before the HSC. I stopped studying completely. My screen time on my phone was like 13 hours a day. I no longer cared. The reason I still did well was because I had worked hard and I had done the groundwork and I had studied. It wasn't that I just took 2 weeks off. But burnout is inevitable for a lot of people. It will happen, but it's about managing it and it's about making it so that you can come back from it. For an example, just this last 2 weeks, I've had a really, really massive couple of weeks at work, at uni, and with some extracurricular stuff that I do with the Law Society at uni. And I really, really needed a break. And so I took about 2 days off work so I could get better. I said no to some things that I feel like I couldn't fit into my schedule anymore, and now I'm feeling a lot better. And I've preempted that burnout and prevented it from becoming 3 weeks long and just let it be a week that it was. So it's very, very important. All of this comes back to you staying in touch with yourself. A couple other little points is try your very, very, very best to stay up to date in your maths class. Staying up to date is going to save you so much time when it comes to maths, because I think we've all had that experience where we fall behind once and then we're like, oh my gosh, I am perpetually behind. I'm never going to catch up again. So trying your very best to stay up to date is super, super important. When you do fall behind, you want to learn how to prioritize. I used to do this by cutting my homework in half, and I would only attempt the harder questions, so the second half of the homework, because if I understood the harder questions, it means you probably understand the easy ones. If that doesn't work, do go back, maybe carve out some extra time, but it's important that you don't steal time from other subjects just to catch up on maths because you fell behind. And then, like I said, I would really recommend planning your revision out weeks from the exam. That's the schedule that I think would be ideal. If you can't do it, the priority is getting to this section as soon as possible. My app has loaded, so this is what Forest looks like. You essentially just pick a tree, plant a tree, pick a time. You can go anywhere from 25 minutes to, you can go from like 10 minutes all the way around to 2 hours. And once you've done that and you've planted your tree and you haven't used your phone, you end up with a beautiful forest. This is my forest from this year so far. I've planted 70 trees this year. And it will show you things like when you generally are focused. As a proof of my motivation and my procrastination, I am most focused at 7 p.m., which proves to you that not only do I often start my work late in the day, but I am a bit of a night owl. So it is something that kind of helps you understand, okay, I work best, when I am working later at night, which is something I've accepted about myself, and now I work my revision around that. So it's very important final point, that you learn how you work best and you tailor your revision to those circumstances. Hopefully, if you popped anything in the chat, I've also gotten to you. Best way to study, I get that question every single time. Past papers, timed conditions. Past papers, timed conditions. I'm sending that to you. Past papers, timed conditions. Best way to study. If you're looking for them, they're everywhere on Google, and we have a bunch of them as well if you use our resources. Thank you so much, Year 11. You are going to smash it. I have all the faith in you in the world that you are going to do an amazing job this year. I hope to see you back in our September Head Start lectures. Thank you so much. See you guys.